So we started talking about sampling, about taking a survey. We talked about how to take a survey a little bit, but we're going to start talking a little bit more detail about taking a survey today. So how do we sample? Good and bad. So lots of statistical studies use information from a sample to make a conclusion about the population. And we want to make sure that those results are good, so we have to see how the sample is taken. All right, so Beyonce. You guys have heard of Beyonce. Do you guys think that Beyonce writes her own songs? So that's what we're going to look at today. So what we're going to do is we're going to use statistics to decide if Beyonce wrote one of her famous songs, Crazy in Love. We're going to sample a couple of different ways and see how the sampling method changes. But one way that we can estimate who wrote something, whether it's a poem, a book, a paragraph, whatever it might be, even you guys, if you type up some sort of a essay or something, I can look at it and see if it is your work or not based on this method. So the way that it works is you estimate the average word length in the text that you don't know who wrote it, and you compare it to text that you do know that they wrote for sure, okay? And you look at the average word length. Because generally speaking, whatever vocabulary you have is going to have a certain word length, and whatever you write will have a similar word length no matter when you write it, okay? So what we're going to do is I gave you guys lyrics to this song, Crazy in Love. So you have all of the entire song here. And what I want you to do is just randomly pick 5 words, any 5 words. I want you guys to circle any 5 words in the song Crazy in Love on the pink paper there. And you're going to just circle any 5 words randomly selected. Any 5 words, whatever 5 words you want it to be, randomly select 5 words. Quickly just circle any 5 words in the song, and then you're going to write down the words underneath number 1. Any 5 words on the pink paper with the Crazy in Love lyrics. All right, and then you'll write them underneath number 1 on your notes. Write those 5 words that you selected underneath number 1, and then count how many letters each of the 5 words that you selected. Count how many letters they have. And then you're going to basically just average those words, those word lengths. So take your 5 words, however many letters they have, add those numbers up and divide by 5. And that would be your average word length for your random selection. Okay, so your random selection, you should have your average word length. And what we're going to do is we're going to create a dot plot of your data. Okay, so what I want you to do is round to the nearest half, whatever your number is. So if you have like 4.3, round that to 4, or up to 4.5 actually. Yeah. So every 25 rounds. All right, so let's do this. What was your average? 6.6. So we'll do 6.5 for you. All right, what was yours? Get your average. So just take the number of letters in each word, add them all up, and then divide by 5. What was yours, Isabella?
6. Are we running up to like the whole number?
What was your actual average?
5.6.
5.6. So then that would actually go to 5.5.
I chose God.
5.
5. What was yours, Xander?
I got right at like 5 for all 5, so it would be 3.
So it's 3, yeah. All right. Royce?
I cut me for all 5, so it's 2, right?
Yep. All right. Oh, okay. All right. So now you got it. Okay, cool. Isabel?
Put it on the dot plot? No, dude, it says
Just tell me, you're writing down your 5 words underneath number 1, and then your average word length, and then you've already told it to me, so now it's on the dot plot, and we're gonna copy this down once we got them all. So, Isabel, what'd you get? 6. Okay. 6. 6. 3.2. So we'll go to 3. Julie, you look. 6.4. So we'll go to 5 for you. 5.8. Okay. So we'll go to 6 for you. Okay. Over here in the sim. 4.4. Is that what you said? All right, so we'll go to 4.5 for yours. 6. All right, back there. 5. All right. 5.5 for Taylor. Okay, Riley. 6.5. Austin. 4. Ashlyn. 5.5. Okay, all right. And then 6.2, so we'll round yours to 6. Okay, and then 4.4, so we'll round yours to 4.5. All right, so there they are. So based on this dot plot, what does it appear that the average word length is in the whole song?
6.
Looks like it's around 6, right? Okay. So that's what it kind of seems like. So here's the deal. Do you think that you were actually randomly selecting words? So we know for sure that some of you weren't because, like Xander, for example, he picked the same 5 words so that the average was easy. So like his random selection was maybe not as random as it could have been. So this is our dot plot of our own personal random selection. And then now what we're going to do is we're going to actually use our calculator. And there is a random number generator in your calculator. So if you guys can all find the math button. It is underneath the green alpha button. And then if you hit the right arrow over to where it says PRB, any ideas what that might stand for? Probability. All right. PRB.
And then you pick random.
And then if you look down, don't do rand because rand is going to do a decimal. But if you look down to number 5, it says rand int. That's a random integer. So go and select number 5. This is rand int. And then most of you, it's probably going to just have an open parenthesis, or it may be asking you for like the lower, the upper, and the number. So what you're going to do is you're going to actually put in the lowest number, and which we're going to have be number 1. If you guys will take your lyrics and flip it over to the back, it's every word has a number assigned to it. And so we have rand int, and we have the number 1. This is right here, actually. So we have rand int, and we have the number 1. And then you'll put a comma, which is right above the 7. And then unless yours is asking for lower and upper, then you can do lower is 1, upper is 297. So 1, comma, 297.
I don't have commas on here.
Comma is above the 7.
It's not.
Why
It's
297?
not.
Comma is just right above the 7.
Okay.
And then 297. Why do we do 297? Because there's 297 words in the song.
Oh, alright.
Okay? And then if you put another comma and the number 5, it will select 5 numbers for you that are between 1 and 297. You can also just put rand int 1, 297 and then hit enter 5 times and it'll give you 5 different numbers, okay? Now, here's what I'm guessing. I'm guessing that most of you probably got 281, 270, 44, 153, and whatever the last number is.
That's crazy.
I am so smart. I can even guess your numbers. Look at that.
That's crazy.
Why did that happen? So your calculator's maybe not as random as we would like it to be. So here's what I want you guys to do. I just want you guys to start hitting enter. Just keep hitting enter a bunch of times. Just hit enter. It should be selecting more numbers for you. Just keep hitting enter. It should be selecting numbers. We're just going to hit enter for a little bit. Some of you maybe hit the enter button really slow. Some of you hit it really fast. Maybe, hit enter a few more times. And yeah, okay, all right. And then at some random point in the next, 15 seconds, you can stop hitting enter and then use the numbers your calculator's telling you. And those are your 5 randomly selected words on the back of your paper.
How do you see the last number?
So when you hit enter, don't hit anything, hit enter and then hit the right arrow. It should go over for you.
Mine's not going over.
So you have to hit enter and then hit the right arrow.
It doesn't do anything.
Yeah,
Yeah, it doesn't go.
Let's see. If we hit enter and then the right arrow. Don't go back up. Just hit enter and then the right arrow immediately.
And then do we plug it? Oh, all right.
Y'all are trying to go back up and highlight it. Don't do that. Hit enter and then the right arrow immediately after the enter. Because you're hitting the up arrow. Hit enter. Now hit the right arrow.
I got the last number on it.
Enter, right arrow. I don't know why. I saw you do it and it didn't do it, but. All right, so whatever numbers you're on now, we're probably random enough at this point. What you'll do is you'll go to those numbers that you have selected on the backside of the lyrics that are now numbered, okay? You'll go to those numbers, and those are your new 5 words. And you need to get the average word length of those 5 words. These are the 5 words that your calculator has randomly selected for you. Yes.
One of mine, words with like the apostrophe and the
The apostrophe, that's a great question. The apostrophe does not count as a letter. The apostrophe does not count as a letter. So like if you get don't, the apostrophe is not a letter. And so now you're getting a new average word length. And you're selecting whichever words your calculator randomly selected for you. And now you should have a new average, and let's see what we got. Avery? 3. All right, so we got a 3.5, okay? 5.
My calculator ran out of
Oh, okay, that's all right. Isabella?
4.5.
4.5, okay. Summer? 3.
2.8.
3.8, so we'll go to 3 for yours. 3.4, so we'll go to 3.5 for yours.
Oh, don't say that.
All right, how about back here?
3.
3. 3.5. Isabel? 3.5. 4.8, so we'll go to 5 for yours. 3.4, so we'll go to 3.5 for yours.
2.4.
2.4, so we'll go to 2.5 for yours. Brianna? 3.2, so 3. Nassim?
So it's just
2.6, so 3.6. Okay, sorry. So we'll go to 3.5 for yours. Okay. 4.6, so that's 4.5. 3.5. 3. 5. Wow. Okay, cool. I think that was everybody. Did I get yours, Logan? Yeah. Okay. All right. So, what do you guys notice about this dot plot?
average is lower.
The average is a whole lot lower than yours. So why were you guys picking such big numbers?
Because they're more appealing.
Because they're more appealing to your eyes. That is 100% correct. Your eyes see the longer words better than they see the shorter words. So your eyes are attracted to longer words. So that's why you guys were randomly picking longer words. Unless you were just trying to pick 3-letter words. Xander.
I just picked repetition.
I know, I'm just teasing you. Yes, ma'am? Yes.
I should have picked me for looking.
All right, so these are our 2 dot plots. One of them you guys randomly selected using your own filter, your own little selection method. This one was done by a random number generator or our calculator. And so which one do you think is more accurate about the average word length of her song?
This one.
This one, yeah. So this one would be more accurate. Does everybody have this dot plot? Can I erase it now? Okay, cool. So let's answer these questions real quick. How is the dot plot from number 4 different from the dot plot of number 3? Obviously, we already answered that question. So the average word length is much smaller. And number 4's average is likely closer to the truth. Okay, so this is your final chance. You are going to take a guess. What do you think the actual average word length is for Beyonce's song Crazy in Love? And you can give it 2 decimal places.
Like. Give it 375.
375?
I'll give it like 8.2.
What?
8.2.
8.2?
I'm gonna say 4.28.
4.28?
6.1.
6.1?
It's like 3 6-letter words in there.
Right.
Actually, I'll give it 5 points.
What'd you say?
325.
325? Write down your guess.
4.28.
Write down your guess in that spot on number 6. Write down your guess.
4.28.
Write down your guess on what you think her actual average is for this song, Crazy in Love.
Yeah, I'm gonna
I
give it
got
a
it, man.
4.8. That's solid.
Okay. All right, everybody has their guess? All right, turn the page. Number 7. Number 7 says, it is known that Beyonce wrote the lyrics for all of Destiny's Child songs. So that was her group back in the 90s. The average word length for all of those songs was 3.64. Based on our work today, do you think that you have convincing evidence that Beyonce did not write this song, Crazy in Love?
No.
Probably not, because it looks like the average word length is around 3.5 based on our random sample that we did. And so it would seem like we do not have convincing evidence. It kind of looks like Beyonce might have written this song. And in fact, I am now going to tell you, hello, welcome. I am now going to tell you the actual number. Her actual average word length was the average word length of this song, Crazy in Love, 3.68.
Oh, I definitely got close.
You were very close. 3.68. If you average all of those word lengths in all 297 words, the average word length is 3.68. Okay? So, do we have convincing evidence that Beyonce did not write this song? Okay, that's what this is asking. So I would say no. The average word length is very similar to her known songs. So we're really close to what we know for sure she wrote. We know for sure she wrote the songs for Destiny's Child. And then Crazy in Love has an average word length that is very similar to the known songs. And in fact, spoiler alert, we do know for sure she did write this song. So that is how we could, but if we did not know that, if we couldn't have Googled it, that's a way we could have done it. Have any of you in history ever heard of the Federalist Papers? You know, some of those Federalist Papers were anonymous. We actually have this very same idea was used to identify the likely authors of each of those anonymous Federalist Papers. Statisticians have figured out pretty well who wrote those unknown ones. So, all right, you guys. So let's talk about a couple of different types of sampling that we could do. So the best, there you go. So one way that we can sample is that we can take a convenience sample. So suppose we wanted to know how much time students at a large high school spent doing their homework last week. We might just go to the school library and ask the first 30 students that we see about their homework. That's called a convenience sample. So here's what a convenience sample is. It consists of individuals from the population that are easy to reach. They're just easy for me to get to. The first 30 students in the library, easy for me to get to. Okay? I just talked to those first 30, I'm done. I got my data. The people who do the surveys at the mall, do you know why they do the surveys at the mall? Because there's a lot of people there and it's easy to get a lot of people's data. All right? So it's just easy. It's convenient. So the convenience sample is something that is easy to get to the people for the person that's taking the interview, okay? Now, is that the best representation of the population? Are the kids that are going in the library the best representation of McKinney-Boyd High School? Probably not. Probably they are maybe kids that either don't want to be around other people or maybe they're going in there so that they can study some. They're maybe not the best representation of the population at McKinney-Boyd. People that go to the mall are maybe not the best representation of everyone in the city. Okay, so convenience sample is a lot of times it's going to result in bias. Do you guys know what bias is? Okay, so it's like a feeling you have or an opinion that you have kind of in a certain direction. So convenience samples are usually going to tend to be biased because they're not going to be getting a good representation of the population. So again, back to this whole 30 students in the library thing. Maybe students who hang out in the library are spending more time doing their homework than a typical student would. So in that situation, our estimation of the true amount would be too high. All right, we would be averaging too high. Kind of like for you guys and the Beyonce example, you were taking averages that were too high because your eyes were attracted to the longer words, okay? So if we repeat this sample process of 30 kids in the library over and over and over again, we are likely going to get an overestimation every time because I'm not talking to the best representation. That is what bias is. So here's bias. Bias is if we get an under or overestimation very often, all right? So a design is bias if it is very likely to underestimate or very likely to overestimate the value we want to know. So if we are likely over or underestimating repeatedly based on the fact the sample method, then we are probably getting a biased sample. very likely to underestimate or overestimate the value we want to know. For example, if I want to take a survey about what people think about avocado toast, and I go to the local donut store, do you think that I am getting a good representation of the population of people who might eat avocado toast?
No.
Probably not if I'm at the donut shop, okay? I know that's very stereotypical, however. People who are eating donuts are probably not eating avocado toast, okay? So we are probably going to get an underestimation of the true feeling toward avocado toast if we are surveying at the donut store. So maybe I need to take the survey at a more neutral place, okay? So that's what bias is. One thing about bias I do want to make sure you guys are careful about, it's not just bad luck in one sample. Bias is not just bad luck in one sample. That's an important point. So, for example, if I am taking this survey about avocado toast and I go to some neutral place like, I don't know, Target, and I'm asking people about their opinion of avocado toast, and I get a whole bunch of people that say, ew, avocado toast, that's disgusting, blah, then maybe that's just one particular sample that I got that was maybe bad. And so if I want to kind of repeat it, if I get a better estimation of the truth about the population, maybe I get a little bit more of a 50-50, then that wasn't necessarily bias. Bias is not just one bad luck of one sample. It's going to always be bad. So that would be, I'm at the donut store asking about avocado toast, and I'm consistently getting a bad sample. All right, so that is bias. And then we have, here's an example. We'll just discuss this example. It's not on your paper, but we'll just discuss this. So a farmer brings a juice company many crates of oranges each week. So think about, we've got these big crates that have oranges in them. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all the oranges. Explain why this sampling method is biased. Is the proportion of damaged oranges in the sample likely greater than or less than the proportion of all oranges in the crate that are damaged? All right, so let's think about this for a second. I'm the farmer, and I've got my crate of oranges. And I know that the company inspector is just going to look at the top. He's not going to go digging through it. It says he's just going to look at the top 10 on the top. What am I going to do with my oranges before I take the crate to the company inspector? I'm probably a smart farmer who is going to put the best 10 on the top so that when the company inspector sees my crate of oranges, they're going to go, oh, that's a great crate, right? And they're going to go ahead and buy it from me. I want to sell my oranges. I want to get rid of these things. So I'm going to put my best 10 on the top, okay? So do you think that this sampling method is going to result in a good estimation of what is in that crate? Probably not. Okay, there's probably going to be some nasty oranges underneath those best 10, okay? So this is probably going to result in an overestimation of the true amount. So this means that the sample proportion of damaged oranges is likely to be less than the proportion of all the oranges that are damaged, okay? Because I'm going to put the best ones on the top. All right. Now we're going to talk about something called voluntary response. Oh, by the way, that was a convenient sample. It was convenient for the company inspector. He just had to look at the top of the oranges. All right, so voluntary response. A voluntary response sample consists of people who choose to be in the sample by responding to a general invitation. Do you guys know what today is? It is election day. November the 8th. It is election day.
Is November 8th always election day?
Yes. Did you know that elections are voluntary response surveys? It is available to everyone who's registered to vote. But does everyone who's registered to vote go and vote?
Yeah, but not everyone.
Not everyone goes. Who decides whether or not they're going to go vote?
Themselves.
Each individual person, yourself. You make the decision, am I going to go and vote? And so I am self-selecting if I want to be a part of the survey or the vote, okay? That is a voluntary response. Now, you'll see right here it says that voluntary response sampling leads to bias when the members of the sample differ from the population. Do you think that the people that are going to go vote today are a good representation of what everyone feels or thinks?
Yes.
You think?
Everyone should vote.
So who are the people that are most likely to go and have their voice be heard? People who are more educated, maybe, or maybe people that are like super passionate about, I don't want Greg Abbott to have to be the governor anymore, like they're super passionate about that. Or I really want to reelect Greg Abbott, right? So it's going to be those people that are super passionate. If somebody's like, I don't really care. I don't have time for this. I'm busy today. I can't go vote. And they're really not that passionate. They're probably not going to go vote. That's usually what voluntary response ends up being. Did you guys know that every time you go to Whataburger, that you are getting a voluntary response survey?
Yeah, you pick what food you want.
Nope, not that. On your receipt at the bottom, there's a survey.
And you can win free water.
And you can actually get a free Whataburger if you take that survey. Did you know that? You can get a free burger if you take that survey. But it's voluntary response. It's on everybody's receipt, but you have to decide to go to the website and take the survey. And so you're self-selecting whether or not you do it. Who is likely to take that survey? People who want a free burger, or people who probably had a bad experience and want to let somebody know. Do any of you work in a place where you work with the public? Who calls your manager to talk about the service that they got or the experience they had? People who are happy or people who are mad?
Karens.
Usually it's Karens, right? Karen is calling your manager and saying, Xander is the worst employee I have ever met in my entire life, and I will never come back to your establishment because of his treatment, right? Karen is not calling up and saying, wow, Isabelle has such a nice smile and treated me with such care and love. Karen doesn't do that. Karen's calling to complain, right? So that is a voluntary response. All right, so here's an example we can discuss. Ann Landers, so she's like this lady who used to do advice column. She once asked her readers of her long-running advice column, if you had to do it over again, would you have children? She received nearly 10,000 responses, and almost 70% said, heck no, I would not have children. What do you guys think? Is that a bad survey? Can it be true that 70% of parents regret having kids? What's wrong with this survey?
It's only
It's
the
me.
people that read her thing.
There it is. It's only for the people who read her particular blog or her particular column. And maybe she is someone who doesn't have kids. I don't even actually know who she is, but maybe she doesn't have kids, or maybe these are people that, like, I don't know, kind of believe or think kind of what she thinks. Also, who's going to respond? Probably people who are like, golly, I hate these children, right? Like, oh my gosh, I need to let this woman know. I need to let the world know. Don't have kids. They're terrible, right? So that's the problem. People who feel strongly about the issue, particularly negative opinions, Karens, are the ones that are likely to respond. So these results are misleading. This is likely an overestimation of the truth, okay? All right, so here's another example. The athletic department at El Dorado Community College wants to learn more about the physical fitness of students at the school, including a number of push-ups that a student can perform. To obtain their sample, the athletic department sets up a booth in the center of campus with a sign that says free physical fitness testing. Why is this sample method biased? Is the mean number of push-ups for the members of the sample likely to be greater than or less than the mean number of push-ups for the entire student body? What do you guys think? Is this a biased sample? Yeah, why? What's the problem here?
Because who's gonna go up to it that doesn't already like
Exactly. Who's going to go up to the thing that says free fitness test? Who do you think's going to go do that? People who like fitness, who are probably already fit. It's not going to be that student that's walking across campus eating the donut. It's going to be the one eating the avocado toast. And so probably this is not the best sample method, okay? So it is likely that only physically fit students are going to go up for the physical fitness testing. Students who are not in good shape are unlikely to volunteer, okay? I sure would not be like, I'd be like, no, I ain't doing that. So as a result, the average number of push-ups for this sample is likely to overestimate the average number that the actual student population could do. All right, and then our final thing is random sampling. Random sampling consists of individuals from the population who are selected using a chance process. Random sampling. This consists of individuals from the population who are selected for a sample using a chance process. The way that we selected the Beyonce lyrics the second time, we used a chance process. We used a random number generator. We were not selecting it using our own biased eyes, all right? And so that's going to be a better way to sample, random sampling. Population who are selected for the sample using a chance process. This is going to reduce bias by quite a bit. So random sampling, again, it's just going to help reduce bias because I'm going to randomly select the people in the population. I'm not going to be biased in any way, the best that I can. Random sampling. Cool? All right, so obviously in the Beyonce activity, our second sample was random sampling. It was a much better estimation of the truth of her actual average songs. All right, so... if we did this push-up example with random sampling, if I just randomly picked people in the college, that would be a better estimation because now I might pick some of the people that are not as physically fit as others, okay? All right, so let's look at our example here. According to a recent article from the Huffington Post, 55% of U.S. adult females sleep with their dog. 12... What's the 12 there for? I don't know. I think that was just, never mind. This report was based on a study from researchers at Kansas College, I don't know, which included the following description of the sampling method. All right, so here's how they did it. Anyone over the age of 18 was eligible to participate in our online survey, but the results in this paper are restricted to female participants residing in the United States who are between 18 and 69 years old. We emailed personalized invitations to 1,229 individuals who had previously participated in studies conducted by the Canine Research Team. Initial and reminder emails included a link to the survey that we asked recipients to share with their friends via email and social media sites. In addition, we advertised the survey on the Facebook page. What are some sources of bias here? Who is going to respond to the survey? So anyone could have responded, but they had to be already a part of the Canine Research, whatever people. And so who's going to take the time to actually click on the link and do the survey? Probably people who are like super excited to be a part of the survey, who are like, oh my gosh, dogs, I love dogs, I want to be a part of this they're already in this canine research thing. So like, it's just all very, I don't know, bias. It's a problem. Do you think that this is likely an overestimation of the truth or an underestimation of the truth? Yeah, this is likely going to be an overestimation of the truth because the people who are responding probably have a dog and are probably sleeping and letting their dog sleep in their bed with them. How could researchers have avoided this bias? Yeah, it could have just been like random in the city. Like we could have randomly selected people just in the city or something. Like maybe we could have gone to the mall and asked random people, you know? So this is definitely a very biased survey.